Okay, the unit circle and common trig values. Before we begin, let's go back real quick and review 30, 60, 90s from geometry and review 45, 45, 90s. Okay, in a 30, 60, 90 right triangle from geometry, everything revolved around the short side. If the short side was 3, the hypotenuse was always double it. Short side was 3, the hypotenuse was 6. If the short side was 3, the longer side was 3 root 3. Remember that. If the short side was 4, the hypotenuse was 8, the longer side was 4 root 3. Short side was 5, the hypotenuse was 10, the longer side was 5 root 3. In a 45, 45, 90, we recognize this as being an isosceles triangle. Because we had 2 equal angles, that meant we have 2 equal sides. If the sides were 3 and 3, the relationship between the sides and the hypotenuse there, you could use Pythagorean theorem, but it's going to be 3, 3, and 3 root 2. 4 and 4, 4 root 2. 5 and 5, and 5 root 2. Okay, what I want to do before we begin is I want to say, what if our hypotenuse is 1 on both of these? Let's talk about what the other sides would be. If the hypotenuse is 1, we know that the shorter side is always half of the hypotenuse. And in order to obtain the longer side, we would have to take that short side and multiply it by the square root of 2. So you'd get root 2 over 2. And in a 45, 45, 90, we know that to go from side to hypotenuse, we have to multiply by the square root of 3. So to go backwards, we would have to divide by the square root of 3. And when you divide by 1 divided by root 3, multiply top and bottom by root 3, you get root 3 over 3 and root 3 over 3. Okay, let's talk about what a unit circle is now, and then we'll get into these common trig values. Which, by the way, you could find your common trig values from these triangles. The sine of 30 is opposite over hypotenuse from yesterday, SOHCAHTOA. Sine of 30 is 1/2 over 1, which is a half. The cosine of 30 is adjacent over hypotenuse, which is root 2 over 2 over 1, which is root 2 over 2. And I hope that you recognize those whenever you saw the stuff there. That 1/2 root 2 over 2. I messed up here. This was supposed to be to go, nobody caught me, to go from leg to hypotenuse on a 45, 45, 90, you multiply by root 2. So we're going to multiply top and bottom by root 2 there. That was supposed to be root 2 over 2 and not root 3 over 3. My bad. And it was supposed to be root 3 on the other one. Yes, it was. Yeah, I flip-flopped my 2. My bad. Thank you very much. Yep. So now, here we go. The relationship between that, write that a little bit better. The relationship between that and what we call a unit circle. A unit circle is a circle whose radius is 1. So what we're going to do, go back and think about how we were graphing those angles yesterday. How to graph a 30-degree angle, how to graph a 45-degree angle. And let's start with a 30-degree angle. And in a 30-degree angle, let me draw me a little right triangle here. Okay, I've got a 30-degree angle graphed. I drew a line straight down. Okay, making it a little triangle, which actually makes it an exact 30, 60, 90 now. And I want to talk about this point right here. This point on my unit circle. If I were to draw a 30-degree angle, and again, notice it's a 30, 60, 90, let's imagine taking this 30, 60, 90 and placing it right here. And talk about what this point right here would represent. Okay, what is the x value of that point and what is the y value of that point? Well, look at this. To go out and to go up to that point, how far out will you go? root 3 over 2, right? How far up will you go to that point? What's the distance here? So this actual point on my unit circle would be root 3 over 2, comma, 1/2. Let's look at what if it were a, let me draw another unit circle. I wish I'd have printed me off a bunch of unit circles so I wouldn't have to do all this. Let's draw me another unit circle. What if I were to graph a 45-degree angle? Just like we graphed 45 degrees yesterday. And let's talk about this point now. Again, notice that all these points are points on this unit circle. If I were to draw a line straight down, to get to that point, again, the x and y values of that point, the x value would be the distance from here to here. The y value would be the distance from here to here. So the x value and the y value are just the exact same values because, again, let me remind you, a unit circle is a circle whose radius, this is the radius of this circle right here. And that's the reason I did both hypotenuses. I did them as 1. Because what if I had a radius of 1? What if I had a hypotenuse of 1? My x and y values on that unit circle, the x value would be root 2 over 2. The y value would be root 2 over 2. Let me do one more. Let's talk about if I were to graph a 60-degree angle. Here's 60 degrees. Let's drop a line straight down. This is 60 degrees. This is 30 degrees. Again, this is a radius of 1. It's a unit circle. If you were to look at this up here, it's the exact same one. It's been spun around now, though. The exact same as this 30, 60, 90. So the side across my 30 is 1/2. The side across my 60 is root 3 over 2. So this point on my unit circle would be 1/2, comma, root 3 over 2. So what's special about a unit circle? We look at these three values. The x value of any point on this unit circle, you can see what it represents. At 30 degrees, the x value is root 3 over 2. At 60 degrees, the x value is 1/2. At 45 degrees, the x value is root 2 over 2. Those common angles that I showed you yesterday. The cosine of 30, if we go back up here, what's the cosine of 30? Adjacent over hypotenuse, cosine of 30, root 3 over 2. What's the cosine of 60? Cosine of 60, here's 60, adjacent over hypotenuse, cosine of 60 is 1/2. What's the cosine of 45? Root 2 over 2. So all these points on my unit circle, what do they represent? The x value of the point represents the cosine of whatever angle I'm graphing. The y value, let's look at the y value now. When you were dealing with a 30-degree angle, the y value was 1/2. When you were dealing with a 60-degree angle, the y value is root 3 over 2. When you're dealing with a 45-degree angle, the y value is root 2 over 2. When you're dealing with a unit circle, the y value of any point on that graph is equal to the sine of whatever angle you've got graphed. Okay, it says, if theta is an angle in standard position, this is the actual theorem. This is what I tried to get across with those drawings. Let me draw another unit circle. If you've got an angle, and it doesn't have to just be 30, 45, 60, it doesn't have to be a common angle. If you have an angle graph, let's say the angle is alpha. And again, remember, this is a unit circle. This is a circle with a radius 1. If angle alpha is an angle in standard position and xy is the point of intersection between that angle, terminal side, and the unit circle, then x is equal to the cosine of alpha and y is equal to the sine of alpha. Now, yesterday or whenever I gave you those common angles, I just kind of had to had to create a way to try to explain to you why the sine of 0 was what it was, and the cosine of 0, and the sine of 90, and cosine of 90. Now, hopefully, I can explain it a little bit better. If this is true, and it is always true, x is always the cosine, y is always the sine. This is 0 degrees. From the other day, does everybody understand that? Here's 0 degrees. If I want to know what the cosine of 0 is, or what the sine of 0 is, I can very easily find it by thinking about my unit circle. Remember that the radius of this unit circle is always 1. And the cosine and the sine relate to the angle graphed on that unit circle and where it crosses. Can anybody tell me what this point is? Ignore the circle. The only thing that you need to know is the distance from here to here is 1. What is this point? 1, 0. Correct? Does everybody understand that? You went out 1, you went up 0. So therefore, if I need to know what the cosine of 0 is, it's right there. If I need to know what the sine of 0 is, it's right there. Cosine of 0 is 1, the sine of 0 is 0. Let's look at 90 now. So everybody understand, on this unit circle, again, the radius is 1. The distance from here to here is 1. So that makes this point 0, 1. And again, this is 90 degrees. So if you need to know what the cosine of 90 degrees is, it's right there. Cosine of 90 degrees is 0. If you need to know what the sine of 90 degrees is, it's right there. Sine of 90 degrees is 1. Okay, we're going to extend this on a little bit further by talking about reference angles. And I told you on tomorrow's test, you need to know sine of 30, cosine 45, sine of 60, sine of 90, which what you're actually doing there, now that I've showed you, is on that unit circle, if I ask you for the cosine of an angle, you're pretty much telling me how far, what's the x value. Like if this is a 45 degree angle, unit circle, what you're telling me is at a 45 degree angle, how far is it from here to here? That's all you're doing. You're doing a little bit of 45, 45, 90 degree math, and you're saying, okay, the x value, the distance from here to here on that point, the distance from here to here, that's what the cosine is equal to. If I ask you for the sine of 45, you're saying, okay, the sine of 45 would be my y value. How far is it from here to here? If this is 1, then this is root 2 over 2, so the sine of 45 would be that root 2 over 2. We can extend that to other angles. And instead of memorizing just 15, we've got lots more that we're eventually going to memorize by using what we call reference angles. A reference angle is simply this. A reference angle is the angle formed between the x-axis and that terminal side. The one that I just graphed, let's say that it's a 135 degree angle. The reference angle of any angle, again, is simply the angle formed between the x-axis and that terminal side. Everybody keep this in mind. From geometry, linear pairs, there's a total of 180 degrees here, which you already knew that from the other day as well. So if I've got a 135 degree angle, and my reference angle is going to be the angle here formed between the x-axis and that terminal side, can anybody tell me what this reference angle would be? The full 180, take away this portion of it from geometry, and you're left with 45. Good. So the reference angle for 135 degrees is equal to 45 degrees. Let's do another one that's in the second quadrant. If I ask you for 160 degrees, if I ask you to find the reference angle, what I do first, you'll get to where you don't have to do this, is I'd probably graph it right now. Let's see, 90, 180. You can label that if you need to. There's 90 and 180. 160 would be about right here. That's 160 degrees, but I need the angle formed between the x-axis and that angle, which would be about, well, exactly 20 degrees. Everybody understand why? Okay, let's go to the third quadrant and see if I even have to teach the rest of this, or see if you already know what's going on. If you're in the third quadrant, again, this is 90 degrees, this is 180 degrees, this is 270. So if we're in the third quadrant, we're somewhere between 180 and 270. If I were to give you the 210 degree angle, And the reference angle, let me repeat it one more time. The reference angle is the angle formed between the x-axis and your terminal side. The line that I just showed, or the arrow I just drew, that represents the reference angle. How do you find the reference angle if you're in the third quadrant? What are you going to do with that 210 to find this angle? Good. Subtract 180 from it. If this is 180, and you need to know how far it is from here to here, take the 210 and take away 180. So a 210 degree angle would have a reference angle of 30 degrees. What if you're in the fourth quadrant? Again, the reference angle is the angle formed between the terminal side. This would be the reference angle here. Let's say that your angle is equal to 330 degrees. 90, 180, 270. We're a little bit past 270, but we're not quite 360, so we're at 330. If you're in the fourth quadrant, and let me go ahead and warn you, if you try the help on your homework, if you try to click the help button, they're going to do this completely different from the way I do it. There's actually 4 different rules that they teach this by. I teach it with common sense. Common sense teaches us that wherever you're at, you can, if you're in the third quadrant, to find this angle, take away 180. If you're in the second quadrant, it's a linear pair. Do 180 minus this angle gives you the reference angle. If you're in the third quadrant, if this is 330 degrees, well, I know all the way around is 360, but I'm not all the way around. I'm a little bit short of it. How do I figure out how much short I am? Take 360 and take away the 330. What is my reference angle there? Somebody got it? 30. All the way around is 360. We're not. We're only 330 around, so do 360 minus the 330 and you'll be left with 30 degrees. So is everybody okay with how to find reference angles? A reference angle is simply the angle formed between the terminal side here and the x-axis here, the nearest x-axis. So one last one. If you're in the first quadrant, and let's say you have a 15 degree angle, the reference angle is 15 degrees. First quadrant angles, reference angles, same thing. But I do want to point out that in all these situations, the reference angle is always an acute angle. Or it's always between 0 and 90. It could be a 90 degree angle. So you need to know that reference angles are always acute or 90. Now, why did I just teach you reference angles? It just opened up your world of trigonometry to lots of new angles. Let's go back to unit circles one more time. Last thing we're going to talk about today. If you have a 30 degree angle, I told you that this point on your unit circle represents the cosine and the sine of 30. The cosine of 30 would be the x value, the distance from here to here, which we found out a while ago and we knew already was root 3 over 2. The sine of 30, which is the distance from here to here, is a half. So this point represents cosine 30, sine of 30. Well, you also have 3 other angles. There's one here at 330. And let me explain the relationship between that 30 degrees and that 330 degrees. 330 degrees has a reference angle of 30 degrees. And do you see the mirror image there? If you know the cosine and sine of 30, then you know the cosine and sine of that's not 330, it's 150. Let's try that again. 150 degrees with a reference angle of 30. If you know the cosine and sine of 30, then you know the cosine and sine of 150. Because they're mirror images of each other. If they have the same reference angle, the only difference is going to be this. The x value is the cosine, the y value is the sine. What's the only difference between this and this point? The sign, yeah, the SIGN signs, the positive and negative signs. This is not going to be root 3 over 2, 1/2. It's going to be negative root 3 over 2, and 1/2. You'll see that? You also have an angle down here in the third quadrant. Let's draw it. It's 210 degrees. 210 degrees also has a reference angle from the stuff we just did. That's 180 and another 30. It also has a reference angle of 30. So if you know what the cosine and sine of 30 is, then you know what the cosine and sine of 210 degrees is. Notice that on this 30-degree angle, you went right root 3 over 2, and you went up 1/2. Okay, again, mirror images, you've got two different types of mirror images. It's reflected this way and it's reflected down, but the distance from here to here is the same. Why? Because this is still a 30, 60, 90. So this distance here is still root 3 over 2. This distance is still 1/2. So the cosine and sine of 210 is left root 3 over 2, down 1/2. The cosine of 210 is negative root 3 over 2. The sine of 210 is negative 1/2. And there is a fourth angle, one down here in the fourth quadrant, which is 330 degrees. That has that same 30-degree reference angle. And since it has the same 30-degree reference angle, it also forms this 30, 60, 90 right triangle. And the cosine of 30 would be, again, positive root 3 over 2. Why? Because you're going to the right. And negative 1/2 because you're going down. So what we're able to do, since you know the cosine and sine, you're memorizing them, you're going to take a test on them tomorrow. Since you know the cosine and sine of 30, since you know the cosine and sine of 45 and the cosine and sine of 60, you now, with this help, you now know the cosine and sine of 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. You now have so many more angles that you can find the cosine and sine of. And I'm going to work one more. We'll do one more for you. Think about the unit circle. You've still got this unit circle. If I ask you for the cosine of 135 degrees, let me explain to you the thought process I want you to have. First off, know where 135 is at. It's between 90 and 180 degrees. And the next step is always find your reference angle. If this is 135, then this must be a 45-degree angle. Imagine that this were a unit circle, okay? And again, this 45-degree angle, or excuse me, this 135-degree angle, since it has a reference of 45, has formed you a little 45, 45, 90 right triangle. And if you know the cosine and sine of 45, then you know the cosine and sine of 135. It's mirror images. On a 45-degree angle, I know the cosine of that, which again would be the x value. I know the cosine of 45 is root 2 over 2. So I know the cosine of 135 would be, it's the same, okay, this distance is root 2 over 2. This is the same distance, but it's in the negative direction. Negative root 2 over 2. So the cosine of 135 is negative root 2 over 2. Okay, here's your little mnemonic device that you can use. And I hope you see where it comes from. To make sure that you get the positive negative signs right, remember this. All students take calculus. ASTC. What this does, and from what I just showed you, hopefully, again, that it makes sense. This shows you what is positive and negative and where it's positive and negative. Okay, this tells you where things are positive. In the first quadrant, all, and when I say all, I mean sine, cosine, and tangent are all positive. In the second quadrant, sine is positive. In the third quadrant, and that means that cosine and tangent would be negative. In the third quadrant, tangent is positive. All other things are negative. We'll talk about tangent in a second and how you do the same stuff for tangent. And in the fourth quadrant, cosine is positive, meaning that tangent and sine would be negative. This chart should make sense because think about sine and cosine. Sine and cosine, which is y and x, are both positive here. As you travel to the left and up, cosine is negative, sine is positive. As you travel left and down, cosine and sine are both negative. And I don't know if you remember yesterday, but I told you the tangent was sine divided by cosine, so negative divided by negative is positive. Tangent would be negative, or excuse me, positive. Cosine here, since x is positive and y is negative, cosine or x is the only thing that's positive there. So all students take calculus. Everything's positive, sine's positive, tangent's positive, cosine's positive. So now here's the steps. Here's how you go through and work these problems without drawing them, because I really don't want to draw every one of them. Step number one, make sure that you memorize, especially for the test, the sine, cosine, and tangent of 0, 30, 45, 60, and 90. Now for 0, reminder, and for 90 as well, if you remember the stuff about the unit circle, and this point here would be 1, 0, then you know that cosine's 1, sine's 0. Same thing here. This point would be 0, 1, meaning that cosine is 0 at 90. Cosine is 0 and sine is 1. If I ask you for the tangent of 90, remember it like this. Tangent is sine over cosine. So, if I ask you for the tangent of 90, do 1 over 0, which is undefined. Tangent of 90 is undefined. Again, I'll show you a different way to do that in just a second. Okay, so here's the process. If I ask you for the sine of 210 degrees, without drawing it, first determine what quadrant you're in. 90, 180, 270, so you're in the third quadrant. Since y is negative in the third quadrant, sine is negative in the third quadrant. So determine your SIGN sine. Also, while you're there, think about what 210 would look like. And I need a reference angle. This is 180. This is another to 210. That would be another 30 degrees. So your reference angle is 30. And honestly, you can now cross that out. Just do the sine of 30. It's going to have the same y value. Well, yeah, but it might be positive or negative. We've already taken care of that. Since you're in the third quadrant, we know that sine is negative. So once you determine positive or negative, we're not worried about this. We're worried about the reference angle now. And the sine of 30 is half. So the sine of 210 is negative 1/2. Another one. The tangent. Let's do the tangent of 330 degrees. Yeah, that'll work. Tan 330. First, determine what quadrant it's in. That would be a fourth quadrant angle. There's 330. If this is 330, your reference angle would be the rest of the way, which would be 30. Well, is it positive or negative? I guess we need that too. All students take calculus. The only thing that's positive in the fourth quadrant is cosine. So tangent would be negative. Your reference angle at 330 would be the other 30, so we don't even need that 330 anymore because we have our negative. So now just do tan 30, which is one of the ones that you're going to have to memorize, root 3 over 3. Done. So step number one, determine which quadrant it's in. That tells you positive or negative. Step number two, find your reference angle and find the sine, cosine, or tangent of it. Done. That's all you have to do to find these different values. Now here is your shortcut for tangent before I forget to give it to you again. If cosine is x and sine is y, then what is tangent? Okay, watch this. If you've got an angle and this is your y value and this is your x value, correct? Tangent is opposite over adjacent, correct? Which is y over x. So you could do y over x if you wanted to, which is, do you see why? That's sine over cosine. That's the reason you can do that. Tangent is sine over cosine. But it's so much more. Is that not rise and run? Back from basic algebra, the rise of this line and the run of this line, is that not y and x? So what is tangent? Ew. Tangent is slope. Y'all see that? If you've got a line graphed in standard position, the y value is going to be your sine, the x value is going to be your cosine, and the slope of that line, because tangent is opposite over adjacent, would be the slope of that line. The tangent is a slope. So that makes things so much easier when you're trying to find, do you remember the slope of horizontal and vertical lines? Let's talk tan. If you've got 0 degrees, what's the tan of 0? What's the slope of 0? Draw that line, what's the slope of that? Is it not 0? What about a 45-degree angle? I used to ask this every year in geometry for this exact reason that I'm about to show you. Does anybody know what the slope of a 45-degree line is? It's got the same rise and run, does it not? And you can do the root 2 over 2 over root 2 over 2, but the slope is 1. What's the slope of a vertical line? It's undefined. Okay, so the tangent of 90 is undefined. And then you've got these other two that, honestly, you just have to memorize. But this gives me a good way of knowing the difference between the two. I used to get it mixed up. One of them is root 3 over 3, and the other one is root 3. And I used to get them mixed up, which one's 30 and which one's 60. The tan of 30 is what, the tan of 60 is what. And then when I thought of it as slope, it made more sense. Does everybody understand that if you divide root 3 divided by 3, it's going to be smaller? This is a smaller number. This is a bigger number. So look at these two. Which one has the smaller slope? You see that that's slanted less? The tan of 30 is going to be root 3 over 3. The tan of 60 is going to be root 3 because 60 is a bigger number. Okay, 60 is a bigger slope, so therefore it's going to be the bigger number. So that gives you a way of finding the sine, cosine, and tangent of all the different angles, all your different common angles.